Hello, so today we're going to do lesson 10. It's domain and range. So you're going to have to open up your slideshow so that you can kind of do some of this with me. And we're going to look at possible inputs and outputs for specific functions. So go ahead and try to do this warm up on your own. So you have this problem and it's the same one we've looked at before. So the total number of times a dog has barked is a function of the time in seconds since the owner tied its leash to a post and left. And less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. So could each of these values be a possible input of the function? So we think about 15. Well, 15 seconds is possible. It fits within a 3-minute window. And so it is a possible input value because our input is the time in seconds. 84.5 is also a possible input value because it also fits within the 3 minutes. And you can have half of a second. 300, however, is outside of the 3-minute mark, and so it would not be a possible input value for this function. Now let's look at the output. So these same numbers, 15 could be the number of total times the dog barked. 84.5, though, you can't have half of a bark. So the number of barks would be a whole number. So 84.5 is not a possible solution here. And then 300, it could be a possibility. However, it's really unlikely that a dog would bark 100 times a minute. And so we wouldn't say that that is very likely. All right, so on your slide, you have notes, numbers out to the side, and I want you to try to see if you can tell if they are a possible input or an impossible input. So this function is the same one we've used before. So the area of a square in square centimeters is a function of its side length, s, in centimeters. And the equation is a of s equals s squared that defines this function. So our input that we're looking at here is the side length. So the side length would be in centimeters. So your possible inputs would pretty much be most numbers. So we could have fractions, we could have decimals. That's how we measure things. Everything in the real world is not in whole numbers. So sometimes they are fractional, like 25 fourths, or 8/10, or 3/5. But what is impossible is for the length of a side of a square to be negative. So it would be impossible to have a side length of -3 or -18. Okay, so if we were asked to describe these input values, we would say that they would be all values greater than or equal to 0. Okay, let's look at another situation. We have a tennis camp that charges $40 a student for a full day. The camp runs only if at least 5 students sign up, and it limits the enrollment to 16 campers a day. So the amount of revenue in dollars that the tennis camp collects is a function of the number of students that enroll. And we have the function R then equals 40N. So go ahead and try to decide if the values are possible inputs or impossible inputs. Okay. So here, your only 2 options are 9 and 15 because we know that the number of campers is the input. That's what we're putting into the function to figure out how much the cost would be. That leaves all of the other values to be impossible. So you might have had 4 and 0 there and maybe 72. Those values won't fit because it has to be at least 5 campers, so that knocks out 4 and 0. They don't have camp if there's not 5. And then 72 is way too large because they limit it to 16 campers. So we would say that the inputs here are values that are greater. So 5 and 16 are numbers. So we would say that it's only allowed if the inputs are between 5 and 16. Okay. A third relationship we have here is between temperature in Celsius and the temperature in Kelvin, and it's represented by the equation K of C equals C plus 273 and 1500. So are these possible values for temperature? All right, so you should have had all of them. Temperatures go positive and negatives. We can have temperatures below zero, and they can be whole numbers or they can be integers, so they can be fractions, decimals. So all of these numbers. So we would say all real numbers would be the input here. Okay. Earlier we looked at this function. This is the same one of the square. So the area of a square is represented by A of S equals S squared, where the side lengths of the square are in centimeters. So I want you to try to name a possible input-output pair of this function. Okay. So some possible input-output pairs you could have had would have been 2, 4, 3, 9, 4, 16, 5, 25. Any of those, you could have written them as an XY ordered pair because an input is your X value and output is your Y value. So you could have had an ordered pair like 2, 4, or you could have written it in function notation like A of 3 equals 9. Okay, any of those. So as long as you picked a point that's on the line, and earlier we described all of these inputs as being greater than or equal to 0 because this line is going up, so it's including all of these values of X. Well, how would we describe the Y values or the range? We're going to call the range. So we are looking now at the values that show up on the Y. Well, here we don't have any negative values, so we would still say that it is all numbers greater than or equal to 0. And so here we're also going to kind of figure out some new numbers. So let me add a fourth pair here for us. So A of 5 equals 25. So our new words, we know that we have X and Y values. Our X values are 2, 3, and 5. Those values can also be referred to as the domain. So your domain is just all of your X values that you have. Okay. Your Y values, 4, 9, and 25, are also known as your range. So now you have 3 words to kind of use as an X, an input or a domain, or Y is your output or your range values. All right, another function was about the campers. So this still follows the same rules as before. You have to have at least 5 campers and no more than 16. And our function is still R of n equals 40n, where n is the number of campers. So is 20 a possible output value for this situation? So we talked about the inputs earlier, and those are the number of campers. So for any number of campers between 5 and 16, would 20 be my answer? And that is no, because it costs $40 per camper, and $20 would be half of a camper, and we can't even have half a camper. We have to have 5. And then what about 100? Well, 100 would also be a no because it's not a multiple of 40. And so we would not ever have anyone pay only $100. Okay. It also doesn't meet the 5 camper minimum. So there are 2 graphs here that relate the number of students and camp revenue in dollars. Which graph could represent this function? So go ahead and use the circle on your slide to choose which graph you think is the correct one, and then describe why the other one cannot represent this function. All right, so the second graph represents this function, and it's because on this graph, we know that the campers have to be between 5 and 16. So this graph, you can see it starts at 5, and it's going to cost $200, and then it only goes to 16, and it only hits whole numbers between there. The first graph, you can see this line is continuous, so this would mean that I could have 4.5 and it would give me a value. But it doesn't make sense for the situation that we're talking about because we won't have any values less than 5 or greater than 16 or any fractions or decimals in there. So how could we describe this set of possible output values? We described our possible input values earlier, our domain, as values being between 5 and 16. So our possible output values, if you're looking at the graph, you can see that it starts at 200 and ends above 600. And if you know your multiples of 40, it would just be 640. So it has to be a multiple of 40, and it has to be between 200 and 640. Because each camper costs $40, we have to have at least 5 campers, and 5 campers cost $200, and we can have no more than 16 campers, and 16 campers cost $640. All right, the last one we were going to look at today is f of x equals 6 divided by x minus 2. So Claire is trying to make an input-output table, and she hits a snag along the way. So what I want you to do is try to fill out the output for each input provided. So if your input is -10, what is your output? 0, what's your output? 1/2. So go ahead and fill that in. Okay. Hopefully you got these values. So if you were unsure or you didn't get those correct, when we're evaluating the function at -10, we're just going to rewrite it and replace x with -10. So you have 6 divided by -10 minus 2. Well, can't do anything on top. -10 minus 2 is -12, and you simplify that to -1/2. Okay. So that's what you should have done on all of those. When you got to 2, can you divide something into nothing? Absolutely not. When you type that in your calculator, you likely got an error message. And so that's where she was having trouble computing this, because f of 2 gives you an error message because we cannot divide by 0. And so let's look at the graph to see why that is. And so we can just type in our function. Okay, and you can see that we have 2 lines and there's a hole in the middle. So on the graph, there aren't any lines crossing 2. And so if I zoom out, you can see that that line gets very close to 2, but it doesn't ever actually touch it. And so that creates a hole in the graph. And that is the exact value that we could not find on the table because we cannot divide by 0. And so it creates an undefined value. So when we're describing the domain of this function, we would say that it would be all values except for 2, because our domain, we had values less than 2 and they had an output, and values greater than 2 had an output, but at 0, it was undefined. So this domain includes all numbers except for 2. All right, so here we have a table, and it's just wanting you to decide if these values could be in the domain and if they could be in the range. And so function Q gives the number of minutes a person sleeps as a function of the number of hours they sleep in a 24-hour period. So decide if you can have negative values, zeros, values less than 1, 24, 25, 60. Can we have fractions? Can we have values greater than 480? What about 1500? So go ahead and jot that down on your paper and see if you think that those are true. All right, so in this table, I've already done it for you. So if our input is the number of hours that a person sleeps, we can't have negative hours because you can't sleep negative times. 0, sure, a person could sleep none in 24-hour period. Could we have values less than 1? Well, they could sleep for a half hour, so that would be less than 1. Could we have values that are 24? Well, yes, it's a 24-hour period, but 25, they're not going to sleep for 25 hours in 24-hour time period. 60? No, we're not going to have 60 hours. We can have fractions because we can have part of an hour. Values greater than 480? No, because that's a 24-hour period. Same thing with 1500. Our range is our output value. So it's the number of minutes that you've slept in the 24-hour period. And so we can't have negative values. We can't have 0 because the person over 24 hours slept 0 minutes. Values less than 1, sure. 24, yes. 25, well, can they sleep 25 minutes in a 24-hour period? Yes. Can you sleep 60 minutes in a 24-hour period? Yes. You can have fractions, values greater than 480. Well, yes, because there are more than 480 minutes in a 24-hour period. But there are not more than 1,500 minutes in a 24-hour period. So the big takeaway today is to understand what we mean by domain and range. And so I want you to just understand that domain is just another way to talk about your X values. Okay, so it gives you a limit on what you can have as your X values. And the range is your Y values. Okay, so hopefully you can remember that. And at the end of your PowerPoint, there are the definition slides that you can go back to for each of those. All right, have a good day.